Hello folks, welcome back to Merrill Math. I'm Mr. Merrill, and today we're going to be talking about finding compositions of functions. So the first thing we have to talk about is what is a function. You probably already have a lot of ideas from, let's say, like an Algebra 1 class about what functions are and how to define functions. In a sense, what a function is something that looks similar to that. So usually we give functions names like f or g or h, some letter. The letter is arbitrary. This is just telling you what the name of the function is. In this case, we have a function and our variable is x, and this is telling you what we have to do with x to get an output. Now, a useful way to think about functions is to think about them as like some sort of construct. In this case, we have this machine that all it does is it takes inputs in and then it outputs certain numbers. So let's say we put in 4 into this function. This function says I'm going to take my input and double it and then subtract 1. So 4 times 2 is 8, minus 1 is 7. So that would be your output. Now when we're dealing with compositions of functions, we're using that same idea of putting in an input into a function and then following it to its output, but we're doing that twice. So with a composition, well, twice, possibly 3 times, sometimes more. There's not really a limit to how many times you can compose functions, but in this case, we're just going to look at cases where we're composing functions twice. Okay, so what we need is another function here. So let's say we have another function and we call it g of x, and that function is the input squared. So we have this function and we have this function. So the question is, how do we compose them? Well, the answer is you're already familiar with how to compose them. The problem that a lot of students have is just with the notation. So in this case, if I want to find what we would notate as down here, let's say f of g of something, so let's say 3. So what happens here is we take our functions and we put them in the correct order, and then we run through these processes, so the f and the g function. So our g function is x squared, and this is what's happening first. Even though f is written first from left to right, when we work through these, we're sort of doing the stuff that's in parentheses first. So we're following the parentheses down to the middle part, and g is right there. So we, in a sense, when we're doing compositions of functions, we actually work from right to left. So we do g first, and then we do f. So our g function goes first, and that outputs into f, and then we get our ultimate output. So if we put 3 into this function, we're going to get something out, and then we're going to take that number and put it into f. And then we get our ultimate output. So g of 3 is going to be 3 squared, which is 9. So we get 9 out of g, and then we take that output and we put it into our f function, which says double it and subtract 1. 9 double is 18, and then we subtract 1 to get 17. So if we're finding f of g of 3, we do g first, then we do f of our output, and then we get this output from f, and that is our answer. Now, when we're dealing with numbers, when we're dealing with arithmetic version of this process, where we have a very concrete example. 3 is a number. We know what 3 does. 9 is a number. We know what 9 is. 17, we're familiar with that. When we have familiar elements in this process goes through fairly quickly. And students tend to take to this a bit better than they would in the alternate case where we're not dealing with a specific number. Let's say we're dealing with a variable. And that's something that's true of pretty much every math process. When we're doing something with numbers, it's very concrete, it makes sense, and it's easy to work through. But when we're working this process with variables instead of numbers, that tends to make life a little more difficult. The thing is, let's look at another example here. When we are looking at this with variables, it is actually the same process. So we're going to use the same functions. We have g here and we have f here still. But we're going to try and find f of g of some variable. Typically, they'll just use x because x is the letter we tend to, the variable we tend to work with the most. So f of g of x. We'll try this in a couple of different orders. We'll do g of f of x here in a moment. So f of g of x. So we're trying to figure out what this output is. So this is saying we start with g, and we're going to input something into g. We're going to get something out, and then we're going to input that into f. So this is our g function, this is our f function, and this is the workflow that we have here. So things are going in this direction. Okay, so our input into g for this case is x. So we put x into here. This says take your input and square it. So my output, not surprisingly, is x squared. Now, this is where students typically get lost. So what happens here? Well, the same thing that happened when we found f of g of 3. So the same thing happened. Last time we got 9 out and we put 9 in here and doubled it and subtracted 1 and got 17. Here, we're going to put x squared in place of this x value here. So this is going to be 2 times x squared, which is 2x squared, and then we're going to subtract 1. That's 2x squared minus 1. And that is it. So when we're composing these functions, this process, again, if I didn't mention it before, this is what we would call finding a formula for this composition of functions, for these two particular values, for these two particular functions, the way we've defined them. So we have 2x squared minus 1. Okay, so what happens if we do it in the other order? Do we get the same thing? What about g of f of x? A lot of times when we're doing things mathematically, we tend to encounter this concept that basically states when we do something one way and we do it backwards, we get the same thing. Addition or multiplication, those are really good examples. 3 times 5 is the same as 5 times 3. 7 plus 4 is the same as 4 plus 7. This process is called commutativity, so things can happen in any order. In the case of composition of functions, as we'll find, in only certain cases is it possible to do your composition in two orders, so we can switch from G to F or F to G and still get the same output, and that's a special case. So in this case we have F going first and G going second, and again our workflow is moving in this direction, so things are going this way. So if we want to find g of f of x, that means we have to put x into this function machine thing here. So if we put x in here, my output is 2 times my input minus 1. That's 2x minus 1. If I put this now into this function, into this machine, my output is going to be this thing squared. So 2x minus 1 squared. And technically we could be done with that, 2x minus 1 squared. You might have a math teacher, or you might have somebody that says, well, you know, we can actually do this square part, so we can find the square of these. So I've got 4x squared, twice their product, so what is that, minus 4x? and then this last term squared, so plus 1. And this is just an expansion box. So there are videos on this channel dealing with expansion boxes and how we can do these things. There are also shortcuts if you're squaring a particular trinomial. So in any case, when you are working through this process, the compositions of functions, finding a formula is usually the hardest part when you have variables going on. Now, you won't always have access to, or it's very rare that you'll have access to things like this, these little pictures of machines to kind of help things look concrete. So when you're working through, homework problems or test problems, you're working through problems on your own, they're not going to look like this. So this is where we get into the notation stuff. So let's work through some examples of these problems where we don't have access to little trinkets and things like that. So as we're looking at these problems, we'll take a look at some composition stuff here. So f of x, we'll say is 3x minus 4. And g of x is, let's see here. How about something squared and add something? How about 2 more x's? Okay, so this is our definition for g of x. This is our definition for f of x. Now we have to do some composing of this. So if I want to find, let's say, f of g of, let's make it something simple. How about 1? So the first step in this process is to start with g of 1. So we're working these, in a sense, from right to left. But really what we're doing is we're starting with the middle parentheses, so the parentheses that are closest to the center. So we're starting with g of 1. So that means we want to find f of g of 1. So our output for this particular function at 1. So in order to find g of 1, I'm going to come down here. That means I have to input 1 for my x's up here. So in place of the x's. So 1 squared plus 2 times 1. 1 squared, that's easy. This is 1. 2 times 1, that's 2. So I have 1 plus 2, which is 3. So g of 1 is 3. This and this are the same thing. This is the output of this function for this input. So just like with our machines, we take the output and we feed it into the next one. So this now becomes f of 3. So if I want to find f of 3, that means I put 3 into my f function. It has this name. This is the format for it. So my input is 3. That means wherever I see an x, I should put a 3 instead. So f of 3 is 3 times 3 minus 4. So this 3 and this minus 4 came from right here because we're working with f. This, again, is just arithmetic. 3 times 3 is 9. 9 minus 4 is 5. So our final answer is 5. Part of the frustrating thing about this process is you end up getting 2 answers. So you get g of 1 first, and a lot of times students just want to stop there. Or they'll want to find g of 1 and then f of 1 and then multiply them together. That's not the same thing that's happening here. That might work in some cases, but that isn't what this process is. The composition of functions is basically feeding an output of one function into the input of another function and then working through that process. So how would this particular, these particular 2 functions, how would they work if we tried to compose them? So if we did something like f of g of x. So if I have something that looks like this. Now my g function, again, is what we're going to work with first. So we find the output for g, which we remember from above is this, is x squared plus 2x. So that means down here, what I'm finding is f of x squared plus 2x, because that's my output of g of x. And I'm feeding it into my f function. So my f function says, take your input and triple it, and then subtract 4. So this becomes 3 times my input, and then I subtract 4, because this is what f does to an input. It triples it and subtracts 4. This is basic algebra 1 stuff. This is distributive property, so we're going to need to distribute here, and we're going to have to combine some like terms. Possibly, if we run into that, it doesn't look like we will in this case. We have 3 times x squared is 3x squared. We have 2x times 3, that's 6x. 2 times 3 is 6, that gives me 6x. And then we have the minus 4 that comes along for the ride. So in this case, we get this. This is our formula for f of g of x. So if you're doing a lot of composing of function stuff, if you're composing a lot of different things together, this would be a great way to, if you're especially using f of g of, some input, f of g of 6, f of g of 9, f of g of 12, if you're finding a whole bunch of outputs, it would be quicker to find your formula and then plug numbers into your formula. For example, we found f of g of 1 above, and we ended up with 5. If we find f of g of 1 here, if we put 1 into this formula, I get 3 times 1 squared plus 6 times 1 minus 4, and that gives me 3 plus 6, which is 9, minus 4, which is 5. So if we plug 1 into this formula, we can find f of g of 1 very quickly by just plugging it into this, instead of having to find g of 1 and then take that and plug it into f and find f of 3. So notice that we still get 5, it still works, but this can be a little bit quicker if you're doing multiples of a composition. So finding compositions, understanding the process, understanding the thought process that's involved, and sort of thinking about compositions of functions as being these sort of input and output machines. If you have, different functions, you can have different things, different ideas that go into these functions, and one output feeds into the input of another function. That is conceptually a good way to think about compositions. The other way, which I tend to prefer to think about, is if I'm finding f of g of x, it just means I'm taking this whole piece and putting it into my variable right here. Or if I'm finding g of f of x, I'm taking this piece and plugging it into my variables here. So either way, it's the same process, but it just sort of feels different conceptually a little bit. So that is pretty much it for compositions of functions. If you have any questions, comments, points of clarification, you can leave those in the comments below. Otherwise, thanks for watching.